So in terms of the overall methodology, if I go back to the team, you have a business analyst, an architect, a data scientist, and then an enterprise software engineer. Now, it looks like there's a neat handoff between all of these people. The reality is that there isn't. But this is more an idea as to who owns that, so who should be the decision maker. But everyone's involved at every stage. So business process analysis, determine high ROI opportunities. The thing is, not all high ROI opportunities are doable. So, which means that you need to determine the doable high ROI opportunities. Identifying measurement criteria. So these are all kind of business analysts. Then identify ML opportunities and use cases. And this is kind of going back to doing the TPE type of analysis to understand what sort of models can I build, where does machine learning, how can machine learning or AI improve a process. Identifying the resource needs, so determining like, okay, well, this is like, what do I actually need in order to implement the project? Then you go into the data scientist, so then you kind of prepare the training data, design and train the model, evaluate the model. So curation and preparing of the training data is a very intensive process that can take months in some cases to be able to get the right training data. But the data scientist should kind of take the lead there. And then finally, you have the deployment and integration of the model, which is the software engineer. And then going back to determine the business process impact. So the PDCA cycle is embedded in this whole thing. So if you kind of follow that overall process and those ownerships, the ownership of these things, I think that would kind of be one of you are well served at that point. Moving machine learning into the enterprise, there are a lot of things that need to be thought of. So enterprise, like building a machine learning model in isolation is not a smart thing, obviously. You need to figure out, well, how do you manage it once it goes out there? So data provenance means which data was used to train the model. The problem is that people sometimes lose that information. They construct a data set for training and then it disappears. So you now have a model, but you have absolutely no idea what data was used to train it. And then what version of that data set was used to train it. Because if you're updating that data set for any reason, then your model no longer reflects the underlying data set. So being able to do version control of your training data is suddenly an issue. Scope is basically, we talked about that. If your scope is you can either make your scope too broad or too narrow. If it's broad, it's not really giving you much information. It's not useful business information. If it's too narrow, you may not have enough data for that. Then you've got the quality, which, okay, how do you measure your models? F1 score, ROC curve, sensitivity, specificity, like all these things determine kind of what the quality of data is. Versioning is basically a version of the model. You should be able to do A/B testing always, which means never deprecate an old model unless you are able to test that against the newest one. And so there's an entire process involved in A/B testing, like basically based on the new data that was used to train the new model. How does it do with the old data? And again, with versioning, you need to be able to keep metrics on how good were the models that were actually generated, and do you have confidence in those models? Integration is obviously an issue. How do you integrate your model? Once you've built it, how do you integrate that into the workflow? How do you control it? Security, I'm going to actually there's going to be a short thing I'm going to talk about, which is what are different techniques for hacking an AI model? So kind of thinking about sort of black hat techniques to essentially fool a model. But security is another thing, which is access control in terms of who has access to the training data, who has rights to modify the training data, who has access to the model, who can query the model, all these things. The other thing which is very interesting is, can you extract the original training data from the model? And in some cases you can. It is possible for you to pull out what the original training data was. There are techniques that you can do that, which would be kind of not so great, because then you can reconstruct potentially very private information through the model. Then there's discoverability, which means what models exist where, what do they do, what is their scope. So if I have a whole bunch of models sitting out there, how do I know which model is relevant for my problem? Do I go off and invent a new one? Is there something that already exists in my library that I can actually use? Is there a consistent way for me to access it? Deployment, how do I deploy it into different environments? Monitoring it so you need to be able to monitor continuously your model to see whether there's any change in the accuracy or change in any of the metrics of the model. So essentially having a standardized test set or test data set to constantly check on your model. Then support, obviously, it's actually a good question. It's like, how do you support an AI model? I mean, who's qualified to do it? Because now it's going to be handed over to your DevOps team who supports it. If there's a problem and your model's not producing the right result, does your DevOps team immediately escalate to third level support? Or does your DevOps team have actually ways to diagnose the problem and to be able to make some early assessments as to why, and maybe find a workaround? This is traditional IT support. Are they able to do that? If they can't do that, that's a problem. And that's another reason why AI is oftentimes not ready for the enterprise. And then finally is lifetime. So when does your model need to be deprecated? At what point does your model no longer have relevance? Is there a threshold? So for example, if your model falls below 80% accuracy, at that point, do I discard the model? Or does that trigger retraining of the model? For example, if it's maybe based on a classification, I'm classifying models, I have a classification model, it could be that maybe some of the categories or labels have gone, are no longer relevant. So these are all things that need to be thought out.